Hey guys, how's it going?
Good. How are you doing, Toufi?
Well,
Good, good. I'm growing trees, as you can see. My hair. All right, so we have Dan with us, guys. We've done the first three without Dan, and here's Dan.
Hey,
hey
Dan.
everybody. Good to meet you.
Leonard, why don't you start with the intro and then we can
Sure. So I'm Leonard Kish. I'm a co-founder of the Cortex project, which is built on YouBase, distributed data protocol. I'm here with co-founder Josh Robinson, who is to my, I guess it's to the audience's left, and who's also the author of the Butterfly protocol. And we're here with Toufi Saliba with Earth64 and author of Toda.Network, and Dan Tolliver, who is also a co-author of Toda.Network. And I don't know if you guys have anything else you want to add there, but we're here today to talk about how Cortex, the application, which is distributed web publishing and note-taking application, but it's much more than that we've talked about before. We'll work with Butterfly, which is a distributed DNS system, and how that will work also with Earth64, which enables, we're calling them NFT containers, that allow NFTs to move, and you can correct me if I get this wrong, between, or really to be chain independent and to be lower cost and
abundant and unique.
And unique.
And globally unique.
Globally unique.
To planet Earth.
So I'll just start off, we can kind of go around and ask each other questions, but I'll just start off with one question, which is the one that we get a lot on our Telegram channel, which is, you say ledger-based NFTs versus the Earth64 NFTs. So really, how are these NFTs or these NFT containers different? Let's do it at the contractual level. So normally a contract would be on chain for an ERC-721. How will that be different in the Earth64?
Sure. Place? So the NFT by construct, it's a non-fungible token. If it's non-fungible just to you in the house, but it's it's not necessarily the case for your neighbor, or your neighbor can have a exact copy of it and non-fungible to them or whatnot, then it's kind of like you say, it's like here we have like something that is super unique here, but you have a copy of the Mona Lisa there or whatnot. The core aspect of the NFT is for it to be unique to all of us if you were to have it in the global economy, and not just unique for a single ledger. So current NFTs that are being created on ledger-based blockchains, trying to retrofit the existing ledger-based blockchain to make it seem as if it's unique globally. But any technologist will tell you that it's like, oh, this is only unique on Avalanche, or it's only unique on Ethereum, only unique on Cardano or whatnot. And that's terrible. That's horrible. And I mean, you can have a copy of the Mona Lisa, many different ones, but those that they know me, when I say something that's terrible and horrible, I'm not really being disparaging. I actually criticize things that I like and love, and we can make it work and we can enhance it. So somebody at some point, I feel, can use one of those branches in NFT, in Earth-based NFTs, which is Earth64, to solve that problem for every ledger-based blockchain, if that problem needs to be solved. And how is that solved? And it's basically, when we say Earth-based NFT, it's something that is unique to all of us, humanity, of how we can use that, and all of us identify that it is unique without having to make it questionable. It is definitely unique for all of us. If you go to China, to Russia, to North Korea, to South Korea, wherever you go, it will be identified as if it's unique. So that would be the containers that Earth64 provide. What you put in that container, you can put a song, you can put software, you can, whatever what you want to put in it to You want to put it because it's valuable, and now that it's valuable, you sell the entire container because it can ensure that the container can be owned by a single owner in every block of time. So that's cool, because then if it doesn't depend on a ledger, then it reduces the cost tremendously, and it provides you with something that is unique globally, and it's interoperable and all of the cool stuff. Most importantly, it's super duper secure by construct. So that's at a very high level without explaining the how, because I feel like you're asking me the what. We can get to the how, of course.
Yeah.
I want to know the how.
Yeah.
What's
Josh
that?
wants to know the how.
I want to know the how.
Okay, cool. So there's something that Dan and I authored in the Toda IP a while back, which is a part of the Toda IP is the data structure. What we did with Earth64, it's kind of like we separated certain components from the Toda IP. And one of them is that data structure, because it's a lot easier for computer scientists to understand data structure, even if they just graduated from computer science, as opposed to the entire Toda IP, where we encounter super duper cryptographers out of, without necessarily pointing which universities, whatnot, that they spend 6 months and it's like can't wrap their head around it. Some of them do, some of them. Anyway, point is, it's a lot easier to understand the data structure. And for any computer scientist listening, imagine like a binary search tree that it's fully saturated and complete. For the non-computer scientists, whatever I have said there is not magic. It's something that you use every day. It's like how all your computers operate. So now that is part of the data structure that Toda IP uses. Toda in general uses it, and then Toda IP uses it as well. And effectively, every block of time, it provides a map for all the computers to work in a distributed way while they are ensuring that they cannot deviate from that map. So it can give you something deterministic, which is the hash of the entire block. So that's one of the benefits of it, that it's taken in the actual Toda IP transactional pillar. The other pillar, which is the data structure, it doesn't necessarily need to depend on that pillar. You could use the Central Bank of England if you want, or you can use Bitcoin or Ethereum, whatever what you use for the actual transaction itself. The elements in that data structure, which is, if you imagine that binary tree, and the very bottom of it, let's say you have the leaves. Each and every leaf, it has unique number in that data structure. So while that data structure can ensure uniqueness, we linked it to Earth's geo coordinates, because one of our projects called Land, and they already done the job, created something called SATO servers. SATO servers, they're basically software containers that they have the characteristics that each and every software container can contain an NFT, can contain anything of value. You can put pennies in it, you can put dollar. But with Land 32, what you can do, you can put, you sign, if somebody owns the land, they put the land, because it happens to be the land that they own is over their geo coordinates. Okay, great, that's fantastic, doing phenomenally well for Land 32, but then there's a lot of it that is over the ocean and glacier that is not being used by anybody. Yet it still have the unique characteristics, okay? Geo coordinates, for those that they don't know, they're one of the very, very few things all of us on this planet agreed for them to be the same everywhere. So we live in year 2021, and despite our civilization to be super modern, we don't have a lot of things that all of us agree to. This is one of them, so that's great. So we use them, but what other things we use to ensure the uniqueness? Because many people, they say, it's like, okay, well, great, you create them, you worked so hard on this technology to put it in there to ensure the ownership and all of this stuff, but what if you end up opening it and it's open source, and then Cisco decide to copy you, or somebody decide to copy, and then you don't have it anymore? So what we also did, we created timestamp on algorithmically. We built it in a certain way that, first of all, we timestamped it back 2020, May 2020, And then we algorithmically we built it in a certain way that each and every one of those, they inherit that timestamp. So if you're using it in your own software, and then Cisco, they go and copy it and they want to use that exact geospatial coordinates, they will look like that they are following you, because they're never not going to be able to go back in time. That time machine doesn't work, so they won't be able to go back in time and timestamp it. So you still have not only the uniqueness with the time and space that they're for each and every one of those. You have the basically priori art, and that's huge for any developer. Many people that 30 years ago were building databases for information to be put in the databases. This one, it's more for value to be put into those containers. And then I can get to the details a little more, but like maybe I'll pause here for a second and see if I've captured everybody's attention so far, so I can continue.
Yeah, I think so. I think Josh might have some specific questions though.
Yeah, I mean,
about the actual implementation.
Yeah, I don't know if Dan can add to some of what Toufi's been saying too about the details of how those containers and how the addressing and all of that works, so we can start getting a maybe a better idea on how to actually integrate that in with Cortex and Butterfly and bproto and everything.
Sure. So the way the actual numbering would work when you have the branch, your branch will basically be defined in a single file, and that file will basically look like as if it is somewhere, like let's say here. Okay, so if I give you this branch, you're able to compute and know what are those numbers under it. You see what I'm showing? Okay. I mean, any computer, even from the 70s, is able to traverse that tree, but yet like not a single computer can create all of it. The branch having 2.2 quadrillion of those, each and every one of those can have up to 64 kilobytes. So you would need, if you ever become super duper successful, which I shouldn't say if, I should say when, because I have a lot of belief in you. And it would be, you would need about 16,500 servers, ginormous servers, like the biggest Amazon server they can provide you. However, back to your question, when we give you this along with the actual formula, we would give you a function that gives you the ability to compute each and every one of those leaves right here. And effectively, we would be giving you the two. Effectively, we're giving you that map to get those 2.2 quadrillion. If you want to make them available online, all of them, like I said, 16,500 servers you would need, but you can start with one server, which give you tremendous until you have like, million plus users or whatnot. There's a service that is called tilling that we're providing folks. In the service, you don't have to take it as part of this. You own your thing, you can build your own tilling. But the tilling, what it does is enable anybody with any computer to run it. And it's more like the work, but the work you do it ahead of time, as opposed to like how the proof of work is instantaneous, that you do it like whenever there's a request. But that work is not something that there's a dependency on. It's more so like a work that the service can benefit from. So without the work, you can still function. With that work, you function a little bit better and faster. It's kind of like Google came and said, here, we're going to provide you search for the web. And some people, they're like, why do I need that? I can just go and type the website name and I can get there. If I really wanted the flower shop, I can type the website name. Until folks realize that you don't have the ability to remember every single website or what you're looking for and so on and so forth, and be like, it's a great service. So that tilling thing can provide with that service if folks they want it. So the actual burn, just so we're clear, people that they have ownership of that NFT, they hold on to it and they can burn it on day 233 and beyond, or they can keep it as an NFT. Which means from now until then, they can do a lot of stuff in development, and then would be happy to provide, to connect with the right engineers. They can provide you with the right functions and formulas, so you can get the numbers and build them ahead of time. And frankly, we're super excited to be part of this and part of this project. I mean, we all worked with you guys before in the YouBase thing, and now with this, it's fascinating because it's purposely Earth64 is built for folks that they want to use it like you guys are using it, and like from application perspective in Cortex, it's fantastic. Like the use case, I've been on your Telegram a few times and I saw like 1,000, now maybe 800 people or something like that, that they are super excited to see this coming, because I haven't seen anybody who didn't see it beneficial to them, which is great. I rarely see that in projects. So yeah, Josh, to answer your question, that can be certainly provided if you're ready to start the development early on. If you want to wait until day 233, it would be available to all the public. But I hope that you would be doing it earlier than the entire public. And in fact, we can encourage a lot of the projects that they're building on it to come in as early as possible, start like building this stuff.
How is ownership tracked? Like, how does someone prove that they own a specific NFT, or look up who the owner of an NFT is?
So let's say we start with the very first one that you bought for B Proto, which is NFT 16. You burn it, let's say burn it, and then you receive that NFB. The NFB, it's a non-fungible branch, which is basically, that's the whole tree. You're receiving this entire branch. Okay, so you have this branch. Who owns this? You own this. Okay, you have the cryptographic proof of ownership of this on the day that you have burnt it. Okay, you take that and effectively you own all the 2.2 quadrillion day one. How you want to provide it to your users is up to you. Like Leonard, in Leonard's case, like you're saying, wants to give each and every user 1 million. So let's say in that branch, this is a user here. Let's say this is Joe, and Joe comes in and is a user of Cortex. Leonard signs this ownership here to Joe. Okay, Joe now owns everything that is under that. This is effectively, it's 20 levels above. That's how the 2 to the power of 20 is basically the million. So then Joe, this will get all of those ownership of each and every one of those files that they're under. Now, Joe can subsequently reassign the ownership if he wants, but if Joe wants to send one of those files to somewhere else, they can choose to use Central Bank of England. They can choose to use Toda.IP if they want to have the implementation. They can choose to use Ethereum or Bitcoin or whatever it is, as so long as if they're sending it, let's say, to Alice, and Alice is okay with the Central Bank of England, nobody's gonna stop them from doing it. As long as Alice is okay, he's okay. They basically both saying we trust that Central Bank of England. But if he's sending it to Bob, Bob is gonna be, it's gotta be on Bitcoin. Then they have to trust Bitcoin. How? I mean, almost any blockchain developer can tell you like how they can actually build it to use that and bridge it. But we can. It's more like this is the trivial part of the equation. But again, it requires that the receiver trusts the mechanism that you're sending. If the receiver doesn't want to trust any Ethereum, any Bitcoin, any central bank, truly want it to be peer-to-peer or whatnot, then they can knock themselves out and build it on Toda.IP if they really want to. But they don't have to. They don't have to. They can use all the tools that exist in the world today and be okay to transfer. Take that file and use the whatever mechanism to send it to the other one. It requires both people to trust it, because as much as this entire thing they say trustless, the receiver, there is not a single receiver of Bitcoin doesn't trust Bitcoin. There's not a single receiver of Ethereum doesn't trust Ethereum. So when we say it's trustless, there's still, it's hidden, the word trust somewhere there. We're still trusting what is being used. So I hope that answers the question.
Well, so if there's a transfer of an NFT from one person to another,
Mhm.
is that done in a standardized, like, is there cryptographic signatures that in like
Right.
a trail?
Yes.
And
yes.
what part would the Bank of England play in that transfer?
The
Are
Bank
they
of-
just recording, or wherever it?
They would
whatever
be
bank.
they would be co-signing it basically if it's centralized. I would imagine. Imagine
Okay,
you're a
so-
Central Bank of England, like they hire you. They're like, hey, you know what? These two people they want to transfer. What do you want to give them? You'd be like, well, we're the Central Bank of England. Everybody knows our public key, so we're gonna co-sign with this thing. And when we co-sign it and say that like we co-signed and said that like Joe sent it to Alice, Alice now has that container, owns the container, that and it says that you have signed it cryptographic. If everybody knows how you can sign a cryptographic because you've had the ownership before, so it belongs to your public key and you're able to sign it to anybody. Once you signed it to her, they co-signed in there, you're good to go. You're like, oh, that's it. She's happy. She sees it in her own. She looks at her own container, and from her perspective, she feels like I trust the Central Bank of England, and I'm okay for life. You know.
So is it that cosigner that verifies or prevents the double spending problem?
In this specific case, yes, you're trusting that whatever mechanism that you're using to actually transfer is the thing that you're trusting that they're not doing the double spend.
Okay, so that could be any other blockchain, basically.
100%. Could be Cardano, and it's likely, if you were to ask me, from all the ledger-based blockchains, it's likely to be Cardano before anybody, because they seem to be having a lot faster things to move forward in this direction. But I don't want to really put words in anybody's mouth, but it's possible.
Okay, so it's basically tracking that or verifying that trail of ownership transfers.
Right. So they basically the either an extension to existing blockchain, or somebody can build on a smart contract today. You can build a smart contract sitting on Ethereum and saying like, okay, this is what I'm going to do. When somebody's going to come in from this, I'm going to look it up. I'm going to co-sign it and I'm going to send it to the other side. Or it can be implemented on the actual chain. Like Charles Hoskinson might get excited about it, be like, holy fuck, okay, let's properly do it on the actual chain and not like somebody's doing it on their smart contract, which is much more efficient, of course. As you know, triggering the smart contract is not necessarily the most efficient way of doing things, but it's possible. That's why I call that part is like the actual trivial part, because if Central Bank of England can do it, any blockchainer can do it.
And so the initial NFTs that are implementation that's on Ethereum is basically that root initial ownership that then people can look at to verify that it's transferred to the other or secondary owner or first owner after the root.
Right. Right. The ownership on Ethereum is simply of an NFT on Ethereum that if you burn it, then you receive the NFB. So it is not the actual, and it is not the NFB. It is an NFT on Ethereum, old school Ethereum NFT. If you burn it, then you receive this. And why is that the case? Because you don't want people to use it and they still have that and then resell it or whatnot. Once they burn it, they can no longer resell it. Somebody spent $100,000 on this licensing, they burn it, then they can use this thing, right? So that's effectively, and I say 100,000. Frankly, we have people, they want to sell it for the Bank of England for $1 million. Like it's that popular this thing is, because the problem that it solves, it's ginormous for somebody who's trying to build the CBDC or trying to build decentralized or whatnot. It's the ground that can connect us all.
Yeah. Okay, I think that makes sense. So if I was wanting to verify, like I had a ownership trail, right, of signatures transferring from one person to another, that I could look up if that NFT, the original owner, if that was burnt on Ethereum, and at least know that the start was correct. and then verify it, the different steps and stuff
Right.
on some other authority.
Right, and then you don't. Once it's burnt, you no longer depend on Ethereum whatsoever, because at that point you're basically the reason. I mean, as long as you know that that's the public key. So let's say you have a copy of the Ethereum chain, and the person burned it before you've actually saved that copy. You're good to go. Like what I'm trying to say is that you don't depend on an ongoing functionality of Ethereum to see, oh, is it still burned? Is it still burned? It's once it's burned. If it's burned, it's burned.
What has it been decided in the implementation what type of signatures it uses? Is it the same type as Ethereum and Bitcoin and everything?
Right.
Cool.
It's easier that way.
Yeah. We had that discussion many times with YouBase. And
right. Yeah, when you had the discussion with Dan, and you guys were talking about like different kind of signatures and whatnot. But some other implementations in the Toda ecosystem, they're using different signatures. But I think most of them, Dan, well, you can speak to that perhaps. Like most of them, kind of like, do you want to speak about that, or is it still restricted until they release?
Yeah, I think if we want to talk about the underlying Toda architecture, then we'd have to. The story is substantially different on that side, but in the end, the signature doesn't actually matter on that side. So, right now there's two signatures that are supported: ED 25519 and SECP 256R1, not K1. R1 because it's what various mobile devices like Apple supports. So on that side, it doesn't actually support.
Because Gravitas likes it.
Yeah,
just kidding. Okay.
It doesn't actually support 256K1, so it's incompatible with Bitcoin and Ethereum. Having said that, it's entirely agnostic to that stuff, so we can tack those things on anytime we want. The architecture is designed in such a way that essentially any signature scheme that you want to toss in there, you can plug that in, and it's pretty flexible with regard to that.
Again, what Dan is talking about for the audience is not talking about the data structure people are buying here. The data structure is compatible.
It's a different. Yeah.
It's the actual one of the implementations, which if folks they choose that implementation as the transactional pillar, we call it, then whoever is building that on it can take care of that. Okay, can make it easily compatible, and that's what I'm saying.
Yeah. So that signature trail would include the signature type basically in the trail.
Yeah, that's right.
Okay.
So you're gluing together both. What, for instance, I mean, we tend to think of them in terms of requirements and satisfactions. So you're stating what your requirement is, and then later you're stating the satisfaction of that requirement. And part of stating what the requirement is stating, what kind of curve you're signing it over, or even the fact that, this is elliptic curve digital signature at all. It could be something else. It could be a Lamport signature or something. So it could be a hash-based signature instead of an elliptic curve signature, or it could be, an RSA style signature or something. Like under the hood, none of the machinery takes into account what exactly the nature of those requirements are. So it doesn't lean on any of the properties of elliptic curve cryptography or any of the fancy things that you can do with signatures. That's all just in a box.
Okay. Yeah, basically just transferring ownership from one address to another, or one, even if it's a different key or signature type.
Yeah, you can put a different lock on it, a different set of requirements on it. Yeah.
And how is it resolved if there's or is there a way to assign what the authority is for it? So whether you're using, Bitcoin blockchain or Ethereum blockchain, if you're using a blockchain as the kind of authority for the current version, whatever's preventing the double spend.
Or for the branch, the branch owner can determine that for the entire branch, or you can actually split the branch into 1,000 different branches and have each and every branch have whatever authority that you don't want to, if you want to split it that way.
So it does basically assign that to a specific authority.
Yeah. So effectively, you can say that I burn it on Ethereum. Now I have the actual branch. The branch, I used one of the tilling services that they tilled it down, let's say 20 levels. So now I have like 20, I have 1 million different branches. Each and every branch has 2 billion of those. I choose each and every one of those to be some bank if you want, or you choose all of them to be part of half of them to be Cardano and the other half to be central bank, however you want to do. It gives you the ability as the owner to assign it accordingly. If you really want to, you don't have to, but you could. You can keep it. You can keep it all using just the tilling, and you're the only owner, and you're like the app, and you're like, I'm the authority. I am Microsoft. I don't fuck around because I'm Microsoft. I'm just saying. I'm just kidding here. You know what I mean? Like you could be the authority for life for it. You're like, I'm the I have 2.2 quadrillion, and I want to continue to be the authority for it. You don't really need to pass it on.
So if you set the authority at a higher level, that can only be changed at a lower level if you allow it to.
You can't not allow it, actually. That's the beauty of it. You can't not allow it. Like the owner of a single base Earth-based NFT, as long as they've at the time that they choose to fork off and go to somewhere else, you've expressed that they own it, right? Like we're saying, like the authority said, I've co-signed with them, or however it is, or I sent it to them, they own it. They own it from that time, and there's a timestamp going forward. They own it on June 16th. June 17th, you can't go back in time and say, oh, they didn't own on June 16th. They just cut you off, and then they go like, now I want to go and use Cardano. It just, that's the beauty of it. It's just that it's independent. They have once they own it, they're independent.
So is it every node in the tree that is an NFT, or is it just the leaves?
It's actually every node is an NFT, but the way we provide it is a 2.2 quadrillion Earth-based NFTs. When we say that is the leaves. So you can have actually more. You're basically having double that, because when you go up in a tree. But the leaves themselves is 2.2 quadrillion are the ones that are Earth-based, because anything above that, then you're taking a bigger chunk of planet Earth. But if you go to the leaf, it is a square centimeter, and that's what gives you the actual uniqueness that is identified by 194 nations to be unique, because the 7 decimal geocoordinates is the one identified globally. If you go anything more than that, we don't know if it's identified everywhere, but 7 decimals identified everywhere. So the square centimeter is identified everywhere to be unique without having to rely on a ledger. It's beautiful.
And it's a binary tree, so every node will have 2 child nodes.
Right. So when you get to the actual algorithm that we've built in a way that when you get to, let's say, when you get to that leaf, okay, that leaf gives you that binary number. Okay, it is actually long, much longer, but hey, let's say that this is it. Okay, this can only give you a single square centimeter on planet Earth and nothing else. That's the beauty of it. So it is tightly coupled. So if you were to give this to another one, to the same function, it will give you another unique square centimeter of planet Earth. Phenomenal. So it's tightly coupled. We tightly coupled them basically.
Interesting. I think those were my main questions. The last one would be what part of the Earth do I own with my number 17?
Oh, I don't know. I can look it up, but it's
Cool.
you know what the funny part is that initially what we did, we've had two MBA students who go, they were an intern to actually go and chunk all the parts that they're not owned by anybody, because it's not that easy. People say it's like, oh yeah, just like cut it there. No, it's not. It's finicky. But once you actually get to all of those territory, we wanted that each and every one of those one, because you can only have 1,701 of what you have. What Dan has number 2. Oh, by the way, Dan, remind me, we can talk offline. Anyway, you gotta get your Ethereum wallet to get that. Anyway, so you're basically what you have. There's only 1,701 on planet Earth. That's it. We can't have more. Not because we decided that the number is 21 million. It's because planet Earth doesn't have more. This is it. It's finite. It's the finite characteristics that are defined by nature and global consensus that existed 480 years before electricity. So that's why it's super cool.
So likely to be more valuable than a CryptoPunk.
What's that? Okay.
So likely to be more valuable than a CryptoPunk.
What do you mean?
There's 10,000 of those.
Oh, well, I must have misunderstood that.
CryptoBunks. There's 10,000 NFT based digital art pieces. They're going for millions of dollars.
I didn't
now.
hear about that. I didn't hear about that. Sorry. Yeah.
Honestly, too busy.
Honestly, here's what we did with Earth64. Okay. So a very good friend is an economist and is actually very well-known economist. So I'm not gonna like state his name here, but when we're doing it at a very high level, saying it's like if each and every one of those 1,701 they're worth $1 million, is that a lot to planet Earth? And the answer is like it's actually extremely low. Like Cardano on its own is like 47 billion. And this is like would be a total of 1.7 billion that can help every single ledger-based blockchain, every single bank, and every single non-ledger, and every single central implementation, every single and it goes beyond just that. Goes also for the NFTs. Like somebody's doing project that they want to power electronic arts when they're selling video games. They currently have one of the top 5 video games in South Korea, which supposedly is one of the top 20 globally. That they have an LOI from them. So I love working with actual applications to the end users, like you guys are doing, and it goes to show that there's a lot of utility for those NFTs that is not just for banking, not just for finance. We're effectively selling software using the old rails. For us, old is Ethereum. Okay, some people they might see Ethereum is like the new rails. Ethereum is the old rails. Exists. It's already connected to a lot of the entire ecosystem. And every time somebody wants to buy that package of software on Ethereum, and then they spend that $20 of gas or the $47 of gas as if it is today, they feel the pain of like, holy shit, I'm spending $47 of gas to buy that NFT. And then they move this NFT from one device to the next. They spend $10 and it's like, holy fuck. So they feel the pain and they say like, I'm buying it because that's giving me the ability to create a system that can stop it, as opposed to hate it. Like we all have that nature. One of the common things that got us together to partner many times, and we're now partner again, is that we're not haters. We're here to, when we criticize things, we criticize them because we want to make them better. So that gives the ability to every buyer of those to be like, you know what, I can make this better. And I can make it not $30, not 30 cents, not 3 cents, not 0.00001 cent for life. You buy that container and use it as much as you want. That's beautiful, you know?
Absolutely.
Yep.
Cool, guys.
I think we got what we need.
Excellent. Any final points? If not, then I'm 3 minutes late for my next, but I've already messaged that I might be a little late.
You're right on time then.
Yeah.
Yeah.
Yeah, you're right. I'm always 3 minutes.
You're right on
Yes.
Toufi time.
Yeah.
Right. Okay, great.
All right.
Thanks so much, guys.
See you
This
guys. Thanks.